Yo, what's happening, folks? Can you hear me? Can't hear any music. It's definitely playing. Can hear you good. Can you hear the background music? You need to crank the volume up maybe a little bit higher. Volume, Gumboss. Give it a big crank it right the way up. All the way up. Tripping over on chords. Greetings! I feel like it's been a couple of weeks, or nearly a couple of weeks, since we last got together and had a bit of fun. I think I snuck a daytime stream in at some point because things have been a little bit hectic. Big shout out to Outwolf, who's just subscribed, and Rasta, who's just subscribed again. God, it's that way. That way. There we go. Thanks, guys, for your support. 7 months. Legends. Absolute legends. Ooh, thumbnail. Yeah, that thumbnail up there. That's what we're doing today. Yeah, I blatantly stole that from the PicoCTF website. I thought leaving that as the background for the whole thing would make a lot of sense. 7 months, I know, right? Very much appreciated. Anyway, so as you well know, I usually have been doing things on Wednesday nights, and that's been kind of up in the air, so I might sneak one in during the day. But the reason is because Mondays has been super hectic with children-related activities, but today there aren't any, so I thought I'll sneak it in because for the next 9 days I'm going to be in Sydney, and I won't get the chance to stream at all until I get back from Sydney. So I thought better get one in. Otherwise, maybe you guys feel like I'm dissing you and not following through on my promises, which clearly I don't want. So let's get to it. T, I've got my Gyokuro again. What have you guys got? Such a good brew. Tea. Got your tea or your coffee or your water or your beer or whatever it is. Archbishop, are you back on the is it the Irish brekkie? Is that what you were on last time? 9 a.m. beer. The cornerstone of any nutritious breakfast. Hey, picked it. Irish brekkie. Woo! Great brew. Fantastic brew. Okay, so last 2 streams that we did, we focused on CLR interpreted development again. We made some good progress, so I think it's time to go back to doing some CTF stuff that has been requested a little bit more. Now, since the last time we got together, I did actually do one challenge while you were away. So let me show you what that was. And I think you'll be happy that I didn't make you suffer by sitting through it. Yeah, here it is. You remember how we were dealing with this this challenge where you had to correlate IP addresses and like frequencies and stuff and figure out which ones were anomalies. It sounds super easy. It took me like another couple of dozen goes. Yeah, exactly. So I did that off stream and I left the screenshot here just so that I could prove to you guys that I had in fact done it and I didn't want to make you suffer. So that one's done. We can move on. You're welcome. Hang on a sec. Let me just non-full screen that. So there you go. You're if people really want me to go through that again, too bad, because I'm not. It was terrible. Did you just sit there guessing? Look, it kind of felt like that, to be honest. Bandit, no. I'm not doing it again. It was horrible. You know, like, I kind of get the notion of doing it, but I felt like it's probably one of the least enjoyable challenges so far. And that's up against some stiff competition with crypto, because as we all know, I hate crypto. Look, you can see we've even skipped these. And I'm going to continue to skip them. So I think what I'm going to do first is this next one here, this general, like, so just for the sake of clarity, I'm just going to avoid the crypto ones for now because I genuinely don't enjoy them, and maybe we can do a dedicated stream where everyone can help me push through the crypto problems in one go. I just find them completely lacking in fun. So this is what we're going to do. We are going to go into general, and we're going to make a in-out error folder. Oops, can't type. MKDIR. There we go. Any questions, by the way, like, hit me. Hit me as we go. But I hope you've got your tea. I'm not having chocolate because I'm being a good boy. Wget. I should have a little download script that does it for me. Hey, no checks to get. Righto, so what does it say here? Can you utilize standard in, standard out, and standard error to get the flag from this program? You can also find it in problems in-out error on the shell server. Okay, so this is probably just a redirection issue, yeah? So let's +X this thing. If you want the flag, you have to ask nicely for it. Enter the phrase, please may I have the flag into standard and you shall receive. Please may I have the flag? You didn't ask correctly. So I just ran some BS ASUS junk file scanner and it thinks that it can remove 11. Oh! That's pretty funny. Yeah, it looks like I typoed, so let's copy and paste it. Oh. And what is that? Oh, okay. So some of this is junk, and some of it's going to be going to... So if we take standard error and pipe it to dev null... Ah, here we go. Look at that. We've just got rickrolled. That's pretty funny. Alright, so if instead of that we just pipe it to temp data, and then let's go strings temp data. It's just @ symbols. So standard error is full of ats, and standard out's full of rickrolls. Who knows the word? Do I need to keep scrolling? I do need to keep scrolling. Everyone, I should put this on in the background, shouldn't I? Is there a flag in here somewhere? I can't see it, can you? Standard in, standard out, standard error. So I'm pretty sure like we separated these things correctly. But I can't see a flag in here. Can you guys? I'm missing something. Maybe we should just XXD to see if there's anything in here. Nah, they're all just @ symbols. There's nothing in there other than @ symbols. Okay, so it's not being sent to standard error. Right, is that fair to say? I think that's fair to say. Maybe what we should do is have a look at the source of the file. So if we go to Pico, GDB. So let's see what this is doing. Just having a quick scan. So it spits to standard out and to stand error. Oh no. Prints to standard out. Set the, okay, so that's just turning buffering off. And it's calling fopen on something. Maybe you actually need to do this on the target server. That could be the problem. So let's head over there and have a look. Maybe there is a file or something that we need to have it spit out for us. Flag.txt, that's probably why. So if we go that, and we go to address, if we redirect that to dev null, what do we see? Ah, there it is. Oh no, no, that wasn't it. I thought it was spat out at the end there for a sec. Let's point standard out to dev null. Yeah, here we go. That would explain it. And looks like Bandit was right. Standard out. Sorry, standard error, standard error. I should have listened to you. Does everyone understand what we just did there? Pretty standard stuff, right? Web exploitation. We found a hidden flag server hiding behind a proxy, but the proxy has some interesting ideas of what qualifies someone to make HTTP requests. Looks like you'll have to do this one by hand. Try connecting to NC blah and use the proxy to send HTTP requests to flag.local. We've also recovered a username and password for you to use on a login page, eh? Oh, Gombos, I didn't even realize that I let that bad pun go. My bad. Alright, let's go and have a look at this. I'm assuming this is going to be relatively painful. What do we do? Connection refused. Really? Maybe I just wasn't fast enough. So if we go, let's go back up here. Do we have a web one? No. Next directory. We've done it again. mkdir web. And let's go. What is this one called? HTTP3. Okay, so I'm just gonna gvim request.txt, and we'll go connect to, what is it going to be called? Flag.local. Yeah, flag.local. Connect flag.local. I assume that it's going to be on port 80. Let me do something like this: get root HTTP 1.1, and then that's pretty much it. Yeah, should be able to do something that simple. So if we go cat request .txt and cat and pipe that to here, what do we get? LWASD, hello! I'm doing very well, thank you for asking. How are you? And welcome to the stream from the UK. So that must be, mid-morning over there. I wonder why this connection's refused. Try connecting via this and use the proxy to send blah. It's a bit interesting that we can't connect to that server on that port. Hey. Hey, SysUp, how you going, man? Just built a developer security tool that is free. Helps users consume open source code safely. Really? That sounds like quite a tough thing to build. I'm not quite sure what's going on here. I don't really understand. Maybe you have to be on the shell server. Yeah, maybe. That's a good idea. Let's try the shell server. Okay. No apologies needed, man. Well, we're only just getting into the first of the real difficult ones, to be honest. But I'm really not sure what's going on here. Jeez, it's warm in here while I'm drinking this tea. Start sweating soon. Are we going to have to avoid this one completely in NetStat? As in locally, you want to see if we can actually connect? Oops. Man. Is -V for verbose, yeah? There you go, so can't connect. Oh, I see what you're saying. Yeah, I don't know what's going on there, hey. That's strange. Like, clearly, if we get a connection refused, we then see from two different locations, it's probably fair to say that that is, Oh, hang on a second. Oh no, yep, that's definitely it. Maybe this wasn't supposed to be the... Either that, or maybe for some reason this dodgy listener is down for some reason, and we'll have to come back to it. But clearly I'm not going to sit here and bash my head against that for too long, so let's just move on to the next one. This program... Oh, we got another binary. Okay. Echo. Maybe get node check certificate. We'll grab the source. And we'll also grab the binary. Sarav. I assume that's how to pronounce it. This is just Pico from a couple of years ago. Sorry, 2018. There we go. Let's have a look at what this is doing. Okay, so there's only one function, and we are disabling buffering on standard out. What do we have here? We have a buffer for what I assume will be our input, a buffer for what I assume will contain the flag, and a pointer that points to the flag. And we clear the two buffers, set them both to 0. Time to learn about... Oh, okay, form out strings. Right, I think I might know what we're doing here. Flag.text. Let's just put something in the flag file so that it doesn't barf. And then it's basically just doing straight fgets. Which is pretty interesting, right? So does that mean, like, if we run this, chmod plus x echo, and we run echo, I'm assuming that like if we just do stuff like this, we're just going to dump memory addresses. And so one would assume then if we have %s, oof, that's not going to work because maybe there's a null pointer in there. But maybe if we do %x, %s, because we want to find the string, right? Let's do another %s. %s. Oop. So all I'm doing is eventually we're going to hit this flag pointer here, right? At which point this will be interpreted as %s. So you see here we're calling printf on what we're giving it, so we have control over the format string. And when we do these %x's and %s's, we're basically saying pull the next value off the stack. So instead of this, maybe we should go %. Do we go $4s? Percent, is it $4s? There you go. $5. Does everyone know how the dollar thing works? 1% for $6. One would assume that hang on, where are we? That looks like text, doesn't it? Just here. So like if I took out FFB441, like if we did this, for example, and we went .decode hex. No, it's an odd length string. Pizza. Okay, so that's not really looking like the kind of text that we're looking for. So if we go, we'll start to see it, right? One would assume. 82. Okay, so that's the input we've been given it. And we're getting down to, so see this 7825, 7825. That's 25 is our % and 78 is x. So we're slowly ripping through. There we go. Maybe it's something like, hang on, how much is it? It's only reeling in 64, right? So that means if we're not actually seeing the pointer, we should just probably do some math. We've got 64 characters that we can pass in, which we have to bypass. And we should be able to do that given that this is... so let's go back here, cancel. It is a 32-bit binary, so every time we do a %x, we're only getting one pointer out. We should still see it towards the end, right? So if we go print %x times 32. So that's the input that we're able to put in. And you can see stuff at the end here. This is where we stop and the flag probably starts somewhere like this. Is that fair to say? Let's just see what this looks like. We got a new follower. Harasams, I don't know how to say that, but thank you for the follow. What does this look like? Oh, there you go. This is the flag. So, and then there would be a pointer immediately after it. So we should be able to do something like %. Where are we? So it would start about 1, 2, 32, 64, 8, 16, 17. Oops. Percent $17S. Oop, it's not that one. Percent, is it $16S? No, we would need two. We need 2 lots of 64. 2 lots of 64. See, we're actually seeing the content of it there, but we want to utilize the pointer, which should be... Hello, Sato TV. Yes, that's exactly what we're doing. Could use %C. But I'm interested in just like picking the pointer that we know is going to be pointing directly to the flag, which I'm assuming is going to be not long after this. So it's not going to be... Ooh, what have I just done? Sorry. My bad. There we go. We're back. Somehow I managed to fat finger. Hello, KMM. How's it going? We've got another couple of followers. Saket Sarav and KMM, thank you for the follows. Very kind of you people. So if we went %32S, it's got to be around this area, right? Because we're dealing with 4 bytes worth for every single pointer, for every single parameter that we request off the stack. This is a little bit kind of shooting in the dark, but it's got to be around here somewhere, I would say. $S. $35. I'll try just a few more and then I'll try and get more scientific. $36. Mate, oh, I'm so hopeless at typing. What's going on? Okay, we're just abusing this little format print string thing. So we know that our flag exists here. We've got a pointer that points to the flag not long after it. So because you could use %X until then, remove one and then use... Yeah, that's true. That's true. I could do that. Well, actually, that's not technically true, is it? Because the start of the flag, which is here, followed by that, we don't want to actually get the start of the flag. We want to get the pointer. That's the start of the flag. So, like if we went %, 30, hang on, what do we actually get out? What is it? It's 5349. That's basically the string that we're looking for, right? So if we went as far as to go, we went past our first block of 64, which is % maybe 17. No. 18. Have we gone too far? 16 times 4. We have already gone too far. So maybe it's %15. Dollar. I need to get % first. $15. Yes. Just a sec. Now we from here all the way to that 5.3. That's where the flag starts, right? $48. Really? 48 blocks of 4. Oh, it should be on 8, shouldn't it? Because each one of those is hex. So it's 24. So if we went %24 X, that's maybe the terminator. So $25X. Wasn't expecting that. $23X. It's not doing what I'm expecting it to be doing, hey. Oops. $26. $6. Ooh. That's gonna be null again, isn't it? That's gonna be 0. So this would probably then be the tail end. Yeah, I'm confused because according to the math here, right, each one of these, 1, 2, 3, 4, 5, 6, 7, 8, should is basically the equivalent of a pointer that's been coughed up, right? I guess a couple of the pointers could be truncated. %x until the pointer. So there's 24 pointers that we've gone past to get there, to get to the flag, right? So I would have expected if I'd gone %26 x, we would have seen. Oh, here we go. 27. So if that's the case, if we add another 16 to that, what's 27 and 16? 53? So if I change that then to S, it's definitely a pointer, that one, isn't it? Calc.exe. Alright, so if we went %52 hx, you can see where I'm going here. 43, is it? Is it 43? Oh yeah, it's 43. Thank you. Could have spent a lot of time on that. Okay, that looks like the end, doesn't it? Because this is going to be text. PicoHex. That's interesting. Maybe it is actually the address of... Let's try it. Nope. 42. 42 is the answer to everything. 42 $X. That looks very pointery. 42 S. It's pretty. What is the question? Well, I hope there's some fans of Hitchhiker's Guide to the Galaxy in here. So look, let's just be completely clear, right? We pass in printf buff, and what's immediately on the stack after this at the moment is anyone's guess. fget_s flag, size of flag. So flag is still sitting here pointing to it, right? This is effectively what we're trying to reach. So how about if we did... I'm going to forcibly do this way. Now there's 4 characters there and we've only got 64. So that would be 16 times. So let's just see what this spits out when we do 16 lots. So you can see we get past this 64, which is what was on the stack here. Then I would assume that this next block here is a pointer to standard in, right? Now as we're popping more stuff off the stack, where would that have been placed? That's higher on the stack frame. So yeah, I would have assumed then if we get to %08, oh no, we need to put the $sign before that, so we need to go percent like 43.008x like that. Okay, so this is basically saying, I'm going to cheat. Let's do this. As main. So at the point that we call printf, which is here, Oop, I need to put there. Okay, see if you can get the flag. CD. Okay, so let's have a quick squiz because there's a search mem function for ABCD. See how we've got this? That is clearly a pointer in a similar region to this. So if we look for a search mem for that, you can see that there's a bunch, again, all on the stack. Now actually that's not what we're looking for. We want a search mem for this. Okay, so that's on the heap. We've actually got it on the stack, CCBC, so it's a lot further down. So if we do, knowing full well that that's the first argument, the second argument is here, we basically need to go hex of OX, let's go BC minus OX 54 hex 68, which we actually didn't need the hex. It's 104 arguments in. So if we go percent 104 percent X, $X, I'll just let that run. We end up with FFD 198. Oh, I should probably divide that by 4, right? Because that's, yeah, okay, so 26. So percent 26, keep failing my percents and whatnot. So that's off probably by 1 or something similar. We're back in the same region that we were in before. Goober, welcome, how you going? $25X. Oh, I'm so hopeless at this. Percent 25 $X. It's a 0. So why is that the case? So if we go percent 26, I'm taking my sweet ass time with this, aren't I? So here, you can see there's our buffer. And I would assume that's picking the 26th argument off the stack. So if this being 1, then we should take this value, add 26 times 4, which gives us this, right? And if we look at that, so what are we doing wrong, people? Any ideas? Because remember, we're reeling each one of these off every time. Percent 27. Any ideas? 53494854, which we have already determined, is okay, so that takes us purely to yeah, okay, I think I know what's going on now. So we want to search mem. This is what I did wrong. I want to search for this. That's on the stack. We need the pointer to that, which is 70. Yeah, because right now our stack is pointing here, and and 70 points to it. So if we do our math here, it should be 70, but again, that doesn't make sense. Is that really it? Percent $7 X. Was that the address that it was at? Do we get CDB4? Maybe that was the next one. So we need percent 6. Has everyone gone quiet? $804. Yeah, I'm confused. Hey, I don't quite understand why I'm seeing what I'm seeing. Ah, that's where it got to. So it needed to be one more. So is it percent? Where are we? Hang on a second. CC70. Yeah, it's got to be the next one. Percent $8X. There it is. Percent $8 S. Percent $8 S. Woo. Okay, if that's all it is, then we should be able to SSH to the flag box, right? On the shell server. That took a bit longer than I was expecting, my bad. I think it's probably because the arrangement of the variables on the stack is what was throwing me. So let's have a look anyway. What? Am I in the wrong thing? Yes. Whoops. Oh, I've got an NC. Here we go. My bad. So we want to go percent $8 S. And there it is. Sorry about that. That was a bit painful, wasn't it? Using a debugging tool will be extremely useful in your missions. Can you run this program in GDB and find the flag? You can find the file on the shell server. I assume then that there's not much more to it other than just mucking around with GDB. And this is in general. Learn GDB. No. Any questions about that previous one? Because I didn't really do a great job of explaining it. We can quit out of these things now. Okay. General. Which one was this one called again? Learn. File run is a 64-bit binary. SX run. Decrypting the flag into the global variable flag buff. This is going to be a pretty easy one, right? So let's GDB this. Info var. So that's where flag buff is. So let's have a quick look at something. Check sec. Canary is enabled, NX is enabled, PIE is not. Okay, so that's going to be where it is. So if we have a look at main, we can set a breakpoint, put S decrypt flag. If we just break here, and then run it. Parry be parry, hello! Ladies and gentlemen, please welcome a very dear friend of mine, Parry B. Parry, local legend. And he's new to this whole thing. So GDB stands for the new debugger, and it is a utility that you can use to debug applications on the fly. There's a lot of folks in here who can help you with the learnings, Benskis. But yeah, that's basically what it is. It allows you to step through a program assembly line by assembly line to see what it's doing and have a look at the contents of memory and registers and just figure out at almost the lowest level what the program is doing, and from there kind of helps you understand the inner workings, if that makes sense. But it's not particularly helpful right now, is it? Because after decrypting the flag, prints something out. Finish reading the flag in a global variable flag buff, exiting. I'm going to say there's more to decrypt flag than we originally thought. So let's have a look at what this does. So here when I go disas decrypt flag, it's the same as saying disassemble the function called decrypt flag, and this is what it looks like. So we can see that it is, what is it doing here? It's allocating some memory by the looks at fixed size. And then what are we doing? So I'm just doing a quick scan to figure out. It's saying that we are now decrypting the flag. It's doing a bunch of sleeps. What I want to know is it actually doing anything useful? So let's go break at decrypt flag, because that'll stop the software running at the time that decrypt flag is called, and we're going to run it again. So here you can see we have set a breakpoint here at the start of decrypt flag, and now we can see step by step as it's running, right? So I'm just going to skip over a few calls. Aha, see this? So RAX is a pointer. You can see this pointer here, yeah? Flag buff is just a pointer. It's not actually a string, okay? So what we need to be able to do is let it run, and then hopefully our breakpoints are still running. And then instead of interpreting flag buff as a string, we need to interpret it as a pointer, right? So flag buff again. So if we go info var flag, it'll show you all of the variables that have the word flag in them. Here you can see if we go x, xwx basically says I want you to analyze this memory location and present it to me as a pointer that's 4 bytes wide. We should get a pointer here. Now if we look at VM map, which says let's have a look at virtual memory, you'll see that this pointer 602260 lives on the heap, which is where we mallocked. So if we decide to look at that address as a string, we can see the content of the flag that was decrypted. Did that make sense? Yay, it worked. You see me just set a beep. Yeah, pretty much exactly that. My problem was that I was treating the global as a buffer that contained the string rather than a global that was a pointer to the buffer that contained the string. That was indeed an easy one. Righto, how are we doing for time? It is 20 past 8. We've plenty of time left to go. Alright, so what do we want to do? Should we go to this web one or should we go to another binary one? Cast your votes. All right, Bandit. Thanks for coming on, man. Nice to have you on as always. You enjoy your Z's, my friend. Binary Killix. Why am I not surprised to hear you say that? That's 1 vote for binary. It does mean we'll have to come back later and do the web ones. I mean, obviously I'm a huge fan of the binary. Oh, that's 1 vote web. That's 1 each. I need a minimum of, let's say... Oh, you suck at binary. A minimum of 3 votes. Preferably 5. Put your hands up. Binary or web? Anyone? Anyone? It's 1 each. Come on, work with me here. +1, you determine where it gets incremented. Oh, yeah, that's a cop-out, Zarivas. Such a jerk laying it on me. Ooh, web, that's 2 web. Time to watch Java being installed. So sounds like web. All right, let's do the web. Let's do the web one. I assume that I've still got burp running here. Target. Righto, so which one is this one? 17991. Now I'm pretty sure that I included them all by default, didn't I? Maybe I didn't. Okay, I gotta re-enable. Okay, I know what I did wrong. Let's just refresh that. Or am I not? Oh, maybe I'm not routing through PicoCTF through burp. Here we go. And I should see it. Here we go. Okay, cool. All right, so we can see it through burp. Righto. What does it say? We found this fishy website for flashcards that we think may be sending secrets. Can you take a look? There you go. Ben votes web. It's definitely web. 3 billion devices and counting. All right, so what do we got here? Can we actually register and log on? Yeah. Never save. Go away. Ah, test. Admin. Denied. Create card. But I wonder if this is a cross-site scripting one. Question. Is this XSS? Okay, so we list cards. Oof. Isn't that just lovely? So clearly this, I've logged in as a test account that someone else has probably already created. And look at this. That's a little bit upsetting. See how it's just coughed the flag up? You know what? We should probably just... That's pretty upsetting, I'm not gonna lie. Yeah. Alright, so here's what I'm gonna do. Let's register. That's gonna be my password as well. Okay, so if I list cards now, I should get nothing here, right? If we create a card and then go back to listing cards, we should see our question and our answer. Morby, how you going, man? Or lady, or whoever you are. What are we up to? We are just currently working on a 2018 PicoCTF challenge. And the detail of said challenge is here. We found this fishy website for flashcards that we think may be sending secrets. Can you take a look? And we just stumbled on it actually giving us the secret, which we really didn't want. So we're going to pretend we didn't see it. And we're starting again. So what I'm going to do So we're going to create, when we click admin, we get an access denied message. Excuse me. So I'm assuming that like the creation of certain things will result in an error. That's what happens, folks, when you put your password live on stream and you get some other jerk logging in. No trolling on stream. Oh, is that you, Rasta? Well played, well played. That's pretty funny. I deserved that, didn't I? I really deserved that. All right, so the kicker here is this, right? We've got Flask cards. So the question is like, what kind of issues do we get when we're dealing with Flask applications? I would assume that that's like Python. For example, like, can you do stuff like this? So here we're just going to try and find inputs that that cause problems in Flask land. Ooh, see that? So inside question, there was nothing there. Righto, so if we create another one, just to show you, if we did this, 1 + 1, do we get a 2 when we list cards? Yes, we do. Okay, so we can actually execute code under the context of the application, which is clearly a bad thing, right? Now, I took a bit of a leap of faith there based on the fact that this is called Flask cards, right? So what we should probably look at is like when we search for Flask vulnerability, we're probably like doing some kind of expansion or template injection. So let's look at injection. Oops, I can't type. Injecting Flask. Let's have a look at this. Cheat sheet. Flask and Ninja SSTI. So this is server-side template injection. So this might be exactly the kind of thing that we're looking for, right? See this? See if the target is vulnerable. We're running 49 in Twig and 7 in Ginger. Okay, so we can get an idea by doing this as to what kind of things are running behind the scenes. So if we create another card, we'll do that. And then when we list cards, what do we get? We get this. Okay, so that's saying that behind the scenes we're using Ginger 2. So that's the template language that's in place, right? Now we can skip all of the detail. And what we want to do is, okay, you may conduct introspection with locals. So we can actually look at all of the things that are present by looking at this, for example. Let's just have a quick gander at what this does. So, request that application self, get data for JSON globals, JSON encoder, and default globals current app. Let's see what happens when we get this. Just for example. Delete that, create a new card. It might not even work, I may have completely busted it by chopping off that last part, but let's see what happens. Ooh, Flask app. Okay, that's a good thing. So if we instead do, can we get a dir of this thing? Is everyone with me? Ooh. That didn't do what I was hoping it would do. Card is preventing the site from rendering. Is someone else out there trying to do horrible things? Stop being chodes. Someone definitely added something to my thing and busted it. Please don't play. Please don't play with my stuff, or I'll change my account and I'll not tell you what the password is. The second card broke your first card. I don't think so, because there was There was 2. Oh yeah, maybe it did. A card is preventing the site from rendering. Please delete it. Okay, so yeah, it was me. Thank you, Relix. Thank you. All right, so maybe we do need to utilize what this thing here is saying. Like, for example, if you need to read the blacklisted config file, you may access it anyway via this. Extract classes from the app. Arbitrary file reads. Remote code exec. Love these cheat sheets. Second method. Well, we don't need to worry about bypassing filters. So maybe we could just look at the config thing itself. Yeah? Rather than looking for a particular thing. Let's create a new one, and here we'll just do this. Oh, and there you go. That's effectively what they had. So, secret key is PicoCTF. So there you go. Did we all learn something there? Clearly, this had a server-side template injection issue, and in utilizing this cheat sheet, we can see we can actually get the configuration object of the app by pumping this payload in. And rather than looking for the flag entry, I just dumped the whole dictionary, and that's basically what we got spat out here. There we go. Dunsky. Okay. We're back to binary. Everyone hates binary. Authenticate. You get no check certificate. Oops. Copy application. So we'll grab the source and the binary, and let's go and have a quick squiz at what it does. Does anyone have any questions about what we've been doing? Plus X off. All right. I'll take that as a no. Okay, let's have a look at what this is doing. Main does the usual disable output buffering for the sake of listening over netcat. Ignore the usual setting of user IDs, group IDs, blah, blah, blah. Would you like to read the flag yes or no? And then it calls fgetS and reads size of buff, which is 64 bytes. If you say no, it exits. If the word yes appears, then we call read flag. Otherwise, oh, this is interesting, right? Received unknown input, printf, and then it calls read flag anyway. This looks pretty interesting though, doesn't it? Because I would assume that this gives us another format string issue. Okay? Because we clearly have control over buff. Okay, so in other words, if we find no inside the buffer, then we print that. There's no reason for an else. And then we say if we're looking for the word yes, but it's not there, then we're saying, oh, we didn't know what it was. So we can put something else. Now, here's where it gets interesting, because we've got this authenticated flag, which is global. Okay? Now, what's cool about this is authenticated is set to 0, and we clearly have no means in which to set it. Yeah? Hey, Barney. However, the good thing about this printf instruction is because it's yet another format string, we have the ability to abuse format strings to write to known addresses. So we could get the address of authenticated, write it to our buffer. We could basically write any value that we want to that buffer. to that address, and like something as simple as the number of bytes that have already been written, and that would set the authenticated flag to true. At which point, it would spit out the flag. So if it's not authenticated, it says no, you're not authenticated. Otherwise, it's happy. All right. So what I'm going to do is we're going to cat into flag.text. Flag goes here. Now, I'll just reduce this a little bit. Now, if none of this makes sense along the way, then please tell me. So have a look. If we go auth and we type no, it just exits. Type auth and we go yes, it says sorry, you're not authenticated. If we type auth and we say something else, it goes, hang on, and then we're not authenticated. So what we're going to do is we're going to go auth. We're going to go, let's say AAAA. Right? And it'll just spit it back out and say, sorry, not authenticated. This time I'm going to go AAAA %08x. And I'm going to do this a bunch of times. Now, what we're actually aiming to get to is we start to see, we've got our 4 A's here. We want to actually see our 4 A's appear in hex here. So, how many characters of input do we have? 64 again. Okay, so let's run that, and we'll just do this again. Alright, so you see here, we've got 41414141, right? Now, if we go from here to here, oops. Let's go back into here and we'll go the length of this. Each one of those is 1, 2, 3, there's 8 characters, right? And that'll tell us how many pointers there are. So there's 10 pointers that we need to go through. So if we go and run this again and we go AAAA %10, I've got my percents wrong again, %10 $08x. Hopefully we'll get 41414141. We didn't go far enough. We need one more, so it needs to be 11. So 1. So here we should be able to get 41414141. There you go. See that? Okay, so now what we know is that this 10th parameter that we're able to access through this printf bug, we have basically we have access directly to this. Okay. Now, authenticated is something that we can quite easily figure out, right? So if we look at auth and we check sec, there's no PIE, so we know that everything is going to be in a fixed address. So if we go info var auth, we can see that authenticated is at this location, right? Now, if we decide, now if we go like this, python-c, we need to import struct. We can go print AAA. So we don't want AAA, we want struct.pack, a long integer, which is that value, followed by %, what was it, 10? That was 11. 1108x. $x, sorry. Okay, so if we run that, we can get that little payload out. Now if we pipe that into auth, what do we get? 365673. Is that right? Is it? Oh, I've got that completely wrong, haven't I? There we go. All right, so you can see how we've got this 0804A04C. That is exactly the same as the address that we've put in here, but it's actually being interpreted now as an address. So if we change this, so that instead of using %x, we do %n, what will happen is that this will be used as a pointer, and the number of characters currently written to the buffer will get written to that pointer, at which point this authenticated value will be set to something other than 0, right? At which point then this authenticated thing should be fine, and it should spit the flag out. So let's do that on, I assume we're gonna have to SSH to the server to get this one done. Oh no, NC. So let's take that. And there it is. Does everyone understand what we just did? Python 2, yeah, you know, dealing with binary arrays in Python 2 is just significantly easier than in Python 3. And there we have it, solved. Any questions? I find it easier. But anyway, for the sake of this discussion, we can get religious about all kinds of things. What's the multiplication thing you did instead of a... Okay, so hang on, where was that? Are you talking about here? Is that what you're talking about, Relix? I'm not quite sure where the what the question is, man. Oh, okay, yeah, okay. So what you can do, the format string, basically what you can say in your format string variable is, rather than just going %x, 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 %x and doing that like 10 times, and then on the 11th time doing %n, this syntax here basically says if you have a number followed by a $, you're actually specifying the index of the variable that's been passed to printf, right? Does that make sense? So you can see when we were doing this up here, what I did was I just did this a bunch of times until I saw where this was, and then I figured out how many pointers there were, and we can see that the 11th pointer was this. And so in order to use the 11th, all you have to do is go $11 to say I want to use the 11th value, and here I just said format it as a 0 padded 8 character number. So that's pretty much it. So you can use the number followed by a $sign in your format string to say I want to reference this index. Yeah, exactly. Okay, so Ben, the reason why it was useful. So if you have a look at this, right? The value of A is A as an ASCII value. If we look at it as a number, behind the scenes the computer represents A as the value 65, which in hexadecimal is hex 41, right? So what I showed here was when I put 4 A's in memory somewhere, 4 A's basically gets packed to 41414141. So let me show you. If we go print, if we pack, we convert the value of hex 41414141, you'll see it's just 4 A's side by side. So what that allowed us to do was to determine exactly where the input that we control was in this big long string. So we knew that we typed this in, and we wanted to know how many times we had to do this %x thing until we saw the thing that we controlled, which started here. And that allowed us to figure this thing out, okay? And then what that means is I can then change A to the address of this authenticated variable, which we determined here, okay? So then we knew we could use this address like I did here, and create a format string that points directly to the same location, but this time instead of having a bunch of A's, we've actually got a valid address in memory. And then once we've done that, we can use this %n that instead of reading from the address, we'll write to the address. So that allows us to write a non-zero value to the authenticated variable in memory, and that's what makes us think that it's authenticated. And if that doesn't make sense, next time we climb, I will explain that in more detail. Did that help? Did that clarify things just a little bit more? I hope so. And it's a little bit quirky, particularly if you've never seen printf bugs before, format string bugs, I should say, or binary exploits. Okay, cool. That's a win. But yeah, feel free to hit me up in person if that doesn't make too much sense. Okay. All right, next one. What do we got? As the song draws closer to the end, another executable, be quick or be... here we go. This one requires even faster machines. Can you run it fast enough? You'll find the execute. Okay, so this is another reversing thing. So there's a be quick or be dead. Look how consistent I am. Be quick 1, be quick or be dead 2. Make directory be quick or be dead 3. What do we got here? That's just another YouTube video. Copy link location. wget. No check certificate. Alright, so we'll pull that one down. Again, we can bail out on these files. Plus X, could be dead. Is it 64-bit? Yep. Yes, +1 to that Zeribus. I can show you that actually. So if you have a look at man ASCII, this will show what all of the ASCII values, the character values, are represented as in memory. So you can see here, capital A is hex 41, decimal 65. And we don't use octal, or I don't use octal anywhere. Maybe some other people do. But this gives you an idea of what all of the characters are that we type in are represented in bytes in memory behind the scenes. Thanks, Cerebus. That's a good idea. Okay, so let's have a look at this. Actually, before running it, let's have a quick look at it in GDB. Disas main. So what do we got here? Call header, set timer, get key, print flag. Okay, so we'll obviously want to get rid of this set timer call, but we can step over that. Disas. Oh, crikey. Disas get key. What does this do? It says calculate key and then calls puts. Okay, so if we disassemble calculate key, it calls calc. So if we disassemble, as you can see, it's passing in this hard-coded value. If we disassemble calc, oh no. Have a look at this. It's calling itself. It's recursively calling itself. Ugh. And in what conditions is it doing it? There are no conditions, it's always doing it. Bugger. So I have no doubt that this is going to take forever. Disas main break here. Oops. BD1. Okay, fine. Break here. And let's run, and then we'll set rip to this. Have a look at the registers. Where's RIP? Okay, so it is going to where we want it to be. Now I'm guessing this is just going to burn forever. Which isn't exactly surprising. So the question that we need to answer is like, what is this calc function actually doing? Which is a little bit of a pain in the rear. So when we call ourselves, there is actually a test here. This jump. And this jump here. So we're doing a comparison. And when we hit this jump, it's to 128. This is where we bail out. So this condition here basically says, depending on what we pass in, compare that value that we've passed in to the value of 4. If it's greater than 4, then we jump to here. Okay, and so that value that we've passed in, we subtract 1, and we recursively call ourselves. And then, what's in EBX? Okay, EX is the result of that call, which we store in EBX. Then we subtract 2 from it, and do the same again. Subtract that result. Do the same with 3. Do the same with 4. And then once we've got those values, sorry, I'm just trying to understand this myself. Sub that from EBX, move that result into there, into R12, do the same with 4, subtract, and then we add those 2 values together and call it again, and then we multiply the result of that with 1, 2, 3, 4. Add that to the result that we got from that previous calculation, dash it, and return it. Oof. So in other words, we need to basically figure out what this algorithm is. I mean, by the looks of it, it's... Hang on a minute, what is it doing? I'm going to assume it's doing some kind of, not necessarily a factorial, because we're not doing multiplication. But in calling this, info func calc, this calculate key, right? So we start here. Do it with it's just going to be an absolute pain in the ass to emulate. It's like it's taking the current number and the I wouldn't necessarily say it's any more or less easy. I mean, there's only one branch here, right? And that is when the number is 4, i.e. we only have 4 numbers left when we need 5. Sub 1, sub 2, sub 3, sub 4, and sub 5. When we need 5 digits, 5 numbers, which I assume need to be greater than 0. given that we're going to be multiplying. And then adding those two things together. And then once we've got the key, we call this key. So it calculates the key and it puts the key in somewhere. And then it calls puts, which I assume spits. What's this? Done calculating key. Do you have to solve easy tasks before access to later ones? No, you don't. But I'm trying to do them in order, at least within reason. Because, you know, that's kind of what you do when you're doing the CTF in the first place, right? Okay, so what are we going to do with this one? I don't really want to emulate this because it's going to be a pain in the butt. I mean, the way we did it before with factorials was basically Googling for it and then cheating. But this algorithm is a little bit different. What do you mean, how was this one called? When you say this one, as far as it being called is concerned, how is this task called? We call it. We call it ourselves, like it's just a binary that we're invoking directly. If that makes any sense. I'm clearly not answering your question correctly enough. Oh, sorry, what is... Okay, it's called Be Quick or Be Dead 3. I think. Be Quick or Be Dead 3. Why do you ask? Oh, okay, you wanted to grab the binary yourself. That's fair enough. I'm open to ideas. What do you guys think? Keep scrolling. I'm thinking that... Ooh, got another follower, do we? Slavowitz. Thank you for following. Man, I just noticed how sparkly I look. Do we want sparkles still, or shall I go and get rid of the sparkles? Black always looks a bit funny. Still a little bit sparkly. What does reversing mean as the type of problem? It means that you have to spend time analyzing the binary and possibly emulating things yourself. So look, if I go back here, right, I'm thinking what we should probably do is stream Pico reversing. Right, let's just create this. Bang, user bin and Python 2. Yep, sue me. Now, what is it that I want to do? I want to basically emulate what's going on here, right? Because you can see we're calling calc and we're initially calling this with this value. So this is effectively the same as print. Oops. Print calc of copy. There we go. Now, so that means we need to have a function called calc, which is taking some parameter that we need to give it. So what we're doing here is we're saying this line here, right? If the number is bigger than 4, or I should say less than or equal to 4, if x is less than or equal to 4, then what happens is we jump down to cap plus, sorry, what do we do here? We take the value, which is x, we times it by itself and add 2, 3, 4, 5. So, and then we shove that in the result and jump to the end, which is at 128, where we pull that out and return it as a value. So that's effectively the same as return x times 2, 3, 4, 5. Okay, so get the value, multiply it by itself, add it, not times by. Yeah, but you know, partial C equivalent is easier. Yep, that's true. But I'm quite comfortable doing this. Plus, I like reading assembly. Okay, otherwise, we're going to go, let's say, result 1 equals calc of x minus 1. Well, I'm kind of hoping that other people will get the same thing, right? That's basically the way I see. They'll get a bit more of a familiarity with it. Okay, so we call sub ex minus 1, and we store that in EDI, which is the parameter that we're passing into this function. And then we get the result of that in EBX, and then we do the same with minus 2, and we sub that, right? So we can go R1 equals calc of x minus 1 minus the calc of x minus 2. Okay, we can see that here, right? Sub, we take the result of the second one, and we call calc again, and we subtract it. So EBX contains that. Then we get 3 and shove it in R12. And we do the same with 4 and subtract it from R12. So we could probably go R2 is the same as those two, right? Then finally, what do we do here? Subtract that. Then we move that into EAX and we add EBX to EAX. So we can say R3 equals R1 plus, excuse me, R2. Well, I registered just as an individual. Maybe you do need to solve some before you can continue on. But you kind of get the idea, right? All right, so yeah. All right. Okay. What else are we looking for here? Sorry, we got to here, didn't we? So that's where we subtracted, and then we added the two together, and then we pulled x out again, subtracted 5, and called calc again. Righto, so we can go R4 equals calc of x minus 5. Okay, that's what this is doing here. That one there, and then it looks like we just multiply that. Now this imod with 3 I'm going to have to read about. But I can actually figure that out myself. What's been going on? Had to leave. We're just doing yet another reversing challenge. Gombos. Process of taking either. Thanks, that's a good answer, Zarubis. What I'm going to do here is I'm going to break on this and continue. So what I want to see is in EAX or RAX 2. We've got this 2, 3, 4, 6. F sharp, one of my favorite languages. 2, 3, 4, 6. So after this, what changes? And then we take that and we add EBX to EAX and we store that. So I would assume then that once we've got that, we go we add those two. Okay. And so we would add R5 equals R4. So whatever that is coming out, is that disassembly again? R4 times OX1 2, 3, 4. So we times that by 1, 2, 3, 4. And then we add that to R3. I can't type R3. Right? So we get that and then we add it to the previous one. Is that right? Yeah, that's right. And then we store the result of that. Now, what's really important to note is even though this is a 64-bit problem, we're only using 32-bit registers for the result. Yeah? Pretty sure it just stores it back. Yeah, so it returns it. So the thing is, like, we want to make sure that this is only a 32-bit number because every time we do these calculations, if we go over the 32-bit boundary, we're doing unnecessary computation. So what we need to do here is effectively truncate this. So R5 equals R5 mod 1, 2, 3, 4, 5, 6, 7, 8. So that just truncates it so that it's yeah. Now, I mean, there's an assumption there that it's always going to be positive. If it's positive, is that a problem? Anyway, once we've got that, we want to return it, right? Now, before we continue, if we run pre-compute, that's just going to sit there forever. Max recursion depth. Which isn't in any way surprising, right? Because we're obviously completely screwing ourselves over. So what we're going to have to do is, like, have you ever heard of memoization? So if we have something like results, so we want to be able to do like, we want to have like calculate a result for something and store it so that we don't have to do it again. Does that make sense? Yeah. So what we want to do is we want to go, actually, we'll go result equals that. And then we'll have an else case where we do this. And then what we want to do is memoize it. So we can go results, result x equals result. And then return the result. But up here, we want to say if x in results, return results x. Is that what we did? So just to, if 3 in result, no, we'll just do go 2 in results, false. Results 2 equals whatever, 2 in results, true. Okay, just wanted to make sure that my syntax was correct. Now if I run this, we're still going to get our recursion depth nailed. So maybe we just need to go the other way. So this value here is the one that we're starting at, right? Which is pretty big. I'm going to go target equals this, right? So what I'm going to do is I'm actually going to start from 0 and work up. Right? Does that make sense? So if we go for I in range target, calc I, and then print calc target. So we're going to go bottom up instead of top down. So yeah, memoization just means caching of results, right? Jeez, that was quick. Okay, so if that's the case, if we GDB this now, and we go, where are we looking? We want to break on set timer because we don't want the timer. And then if we disass decrypt flag, is that what we were looking for? No, not decrypt flag. Get key, sorry. Calculate key, we want to break here as well. Because calculate key yeah, okay. So that'll return it in EAX. So we just need to set EAX at this point. Okay. So knowing that EAX is whatever this value is. Okay, let's run. Now we need to move rip to here. So set rip equals that and run. What have I done? Let's run that. Oh, I pressed run instead of. I'm so dumb. Continue. Okay, so we get to calculate key. So I'm going to do the same thing here. Set rip equals whatever that is. But then we're going to go set EAX. I'm going to have to struggle to find where I put it now. To this. Okay, let's just make sure. Yep. And continue. Hey, here we go. Printing flag. PicoCTF dynamic programming for the win. Boom. Yeah, I should have just kind of like do the get flag thing. Zarubis, you're going to have to explain to Parry now. Parry, what that means. Because I'm not doing it. Alright, what are we doing? It is 9:15. Oh dear, yeah, my thoughts exactly. Anyway, did what we just do make sense? How long have we got? Yeah, that's a great question. Are there any questions about what we've just done? Because I'm thinking now is probably a good time to draw a line in the sand. We have just about 10 minutes to go. And I did notice that we've got a forensics challenge ahead of us. So I was thinking maybe we can put a bottle on, a lid on it right now. But yeah, we got a few things done. I was a little bit fucked about, a little bit more than I would have liked. But hopefully this deconstruction of this problem made a little bit more sense. So obviously blowing our stack recursively when we start from the top down is a bad idea. But if we do this process and we make sure that for every result that we pre-calculate, we store it so that we don't have to like recursively go down every single time, then from 0 all the way up to where we need to go, we can pre-calculate all of the results for these functions and then just spit out the result, which allowed us to get that hex value out, which we could then set and just allow the key decryption to happen in memory after bypassing the signal checks. And as we can see, it spat the flag out for us. So yeah, that was not too painful. And we did that without having to convert this lovely, highly readable assembly listing to hang on, where is that character? That actually wasn't that hard to read. Am I right? You guys agree with me? Everyone's silent. I don't know whether that's a good or a bad. Okay. Let's go back to close up. All right. I'm gonna put a stop to things at this point. Oh man, my arm looks like it's got holes in it now. There we go. I look human again. Thanks again for tagging along. What a challenge to end with. Yeah, did you enjoy it? I enjoyed it. I quite like challenges like that, and I also enjoy reading assembly, which is why I kind of didn't want to go down the path of throwing it into a decompiler and spitting C code out. It's kind of a nice process to go through manually and figure out what each of those things mean. So, Athuli, you arrived just as we were finishing up. Sorry about that, mate. Parry, thanks for coming in, mate. It's lovely to have you involved. Zarubis, thanks for helping out and answering questions. And to all the regulars for your support, and to the newcomers that are now following and getting involved in the discussion. Very much appreciated. But yeah, you know where to find me on the Twits and on Discord and all that sort of stuff. Jump in Discord, and if you have any questions, then please let us know. But as I said at the beginning of the stream, it's going to be another like 10 days minimum before I get to stream again, because I'm going to be away in Sydney doing some bits and pieces. So apologies for that, but I'll look forward to getting stuck in again when I get back. But yeah, in the meantime, hit me up if you have questions, and as always, be good to each other.